Hello everyone, welcome to the OneClass channel. My name is Marlon. I'm a second year chemical physics student at the University of Waterloo with a minor in math. Today I'm going to be working through some high school level and college level algebra problems. Be sure to check the links in the description if you're in need of any extra homework help or would like some one-on-one tutoring. Okay, so for our first question, we want to define what the zero exponent rule is. So the zero exponent rule simply states that any constant to the power of 0 is going to be equal to 1. So a can be any real number. And the reasoning for this is because you know a to the power of n, where n is also a real number, over a to the power of n is going to be 1. And because of the rule a to the power of b over a to the power of c is equal to a to the power of b minus c. We're just going to apply that here, and we get a to the power of n minus n, and n minus n is going to give us 0. And that's it for this question. Okay, for our next question, we are going to be solving for k. So in part A, we have e to the power of 2k is equal to 5. We are going to take the logarithm to the base of e on both sides. We know that because of the property log a is equal to 1, and log bc to the power of d is equal to d log bc. We will have log e to the power of 2k is going to give us 2k log e. This is going to become 1. So that's just going to be 2k. And we have said that that is going to be equal to log e5. We also need to note that we have a shorthand notation for this. So log to the base of e of any number is the same thing as ln of 8. This is going to be equal to ln 5. And then next up, we just want to isolate the k. So we have 2k is equal to ln 5. Divide out the 2 on both sides. And we get k is equal to ln, ln 5 all over 2. And that is going to be our final answer for that one. Part B. We have 2e to the power of 5k is equal to 8. So for this one, we first want to divide out the 2 on both sides. So e to the power of 5k is going to be equal to 4. Next up, we do the same exact thing that we did last time. So log e to the 5k is equal to log e4. This will give us 5k log e is equal to log e4. This is going to give us 1. So 5k is going to be equal to ln 4. And then you simply divide out 5. So k is equal to ln 4 all over 5. We can rewrite this as ln 2 squared over 5. And this will give us 2 ln 5. Sorry, 2 ln 2 over 5. And so this I simply got from the rule log e to the power of c is equal to c log e a. And we know that log e is just going to be ln a. And that's it for this one. For our last part of this question, we have 3 exponent k over 9 is equal to a. Just be careful with this so we don't get confused. So we have k over 9 is equal to a. Let's rewrite that as 3 e to the power of k over 9 is going to be equal to a. Divide out the 3 on both sides as we did in part B. So e to the power of k over 9 is equal to a over 3. Next up, we want to take the logarithm to the base of e on both sides. Okay, and then we're going to use the property to just bring that right over here. And then we also need to remember, just write down all the properties I'm using. So log a b to the power of c is equal to c log a b. Log a m over n is equal to log a m minus log a n. And lastly, log a is equal to 1. These are the main ones that we're going to be using. Sorry, we have one additional one. I'm just going to place it here. Log e a is equal to ln of a. Log a m over n is equal to log a m minus log a n. And lastly, log base k of a is equal to 1. So next up, we are going to rewrite this, and note that this is going to be equal to 1. So k over 9 is going to be equal to log e a minus log e 3. So k over 9 is equal to ln a minus ln 3. And this will give us k is equal to 9 into ln a minus ln 3. And that's it for this question. Okay, so next up, we want to find which of the inequalities matches the graph. So a good way to just test your understanding of these inequalities is to actually plot all of them and see which one will give you the correct graph. So for option A, we have x is less than or equal to 5. So there are 3 parts of this inequality. We have the number, we have whether it's equal to, and lastly we have whether it's less than or greater than. So in this case, let's start with x is equal to 5. And so when we plot that, we have something like this. At the point 5, you'll have a line. Okay, so this is the line x is equal to 5. But then the inequality is x is less than or equal to 5. So it's both of them, which means for less than, we will have all points before this line that we've sketched out, and including the line. So obviously, this will match what is in the question, and A will be correct. But just to continue on our understanding of these inequalities, let's plot the rest. Next up, we have x is greater than or equal to 5. So we start with x is equal to 5. And then we go to x is equal to 5 again. Get the line. If you want to just mark it, we have y, x. So we have the line x is equal to 5. And then the inequality is going to be x is greater than or equal to 5, which means we want all points beyond the line x is equal to 5 and including the line itself. So that will look like that. So it's almost the opposite of part A. Next up, we'll have y is less than or equal to 5. So again, we start with y is equal to 5. So we go here. Okay, and then we have y is less than or equal to. So I want all points including this line and below it. So on the y-axis, that is 5 and below. So 5, 4, 3, 2, all the way until negative infinity. And that will look like this on the graph. Lastly, we have y is greater than or equal to 5. Again, start with y is equal to 5. So if we define that as that point. And now in this case, we want y is greater than. So 6, 7, 8, all the way to infinity, including the line itself. And so that is all points above the line. And so just as an extra example, if the inequality doesn't include the equal sign, so take y is less than 3, then again, you start with y is equal to 3, but you make the note that in your inequality, y is not equal to 3. And so what that means is that when you draw it, find 3, draw the line, and then instead this time, because of the fact that y is not equal to 3, you can have a broken line, and that'll just signify that we are including all points not including the line. And so since y is less than 3, we want 2, 1 all the way until negative infinity. So it would look like that. And then the broken line just means not including the line 3 itself. And that's it for this question. So the answer is the first option, which is that. Okay, next up, we want to express as a single logarithm and if possible simplify. So let's first write down the logarithmic properties we can see we will need. And so we'll be using log a of b to the power of c is equal to c log a b. And we're going to be using it in this direction. And additionally, log the base of a of b minus log to the base of a of c is simply log to the base of a b over c. And we are going to be using that one in that direction. And additionally, we'll be using the rule that x to the power of a over x to the power of b is equal to x to the power of a minus b. So now, once we begin, we have log to the base of a, x to the power of 8, minus 2 log to the base of b, root x, right? And so in order to use this rule, we see that we have to have the same base and then a number. So we can't have a constant here in front of it. So to get it into that form, we're actually going to use the first rule, this one. We're going to be using it in this direction in order to bring this power 2 over here. And so we get log to the base of b of x to the power of 8 minus log to the base of b of root x squared. And we know that root x is x to the power of 1 over 2. So root x squared is x 1 over 2 squared. 2 times 1 over 2 is just 1. So it's just going to give us x. So let's just rewrite that as log to the base of b, x to the power of 8, minus log to the base of bx. Okay? And then next up, we're going to be using this rule. We see that they have the same base, so it just means that we're going to do x to the power of 8 over x. So this will become log to the base of b, x to the power of 8 over x. And we know that x to the power of 8 over x is the same thing as x to the power of 8 minus 1, based off of this rule. And that would be log to the base of b of x to the power of 7. So in the scenario where b was, if b equals x, then we use a combination of this first one with the fact that log x of x will be 1, and we would get the answer log x to the power of 7 is simply 7. But this is in the scenario b is x. We have not been told that, so this is going to be my final answer. Okay, next up, we would like to solve for w in this. So we have 5w plus 9z is 2z plus 3w. Solve for w means we want w on one side of the equation and everything else on the other side of the equation, so we can say w is equal to something that doesn't include any w's. So first up, we can start by subtracting 3 from both sides. 3w, sorry. These two will cancel, and so we get 5w minus 3w plus 9z is going to be equal to 2z. And this is going to give us 2w plus 9z is equal to 2z. Next up, we want to subtract 9z from both sides so we can have w on its own. These two will cancel. So 2w is equal to 2z minus 9z, and that is going to give us negative 7z. And then lastly, we divide out the 2 on both sides in order to enable them to cancel. So w is equal to negative 7 over 2z. Just in case you don't understand how and why I'm choosing my values, I chose negative 3w here because it would cancel the positive 3w. Here, I chose negative 9z on this side in order to cancel the 9z and bring it over to this other side. And then lastly, since w is multiplied by 2 here, if I divide it by 2, it'll cancel out, and I have to divide the other side by 2 as well. And this will be our final answer. Okay, next up we have a polynomial with integer coefficients and a leading coefficient of 1, whose zeros in degree are given. So we have x is equal to negative 5 with a multiplicity of 1, and x is equal to negative 1 with a multiplicity of 2. So if you write this, we get x plus 5, and since the multiplicity is 1, it's to the power of 1. And we get x plus 1, multiplicity is 2, so instead it's going to be to the power of 2. And so now we just combine those two, and you get x plus 5 and x plus 1 squared is equal to f of x. F of x is equal to 0 at the zeros, that makes sense. Negative 5 plus 5 will give you 0, making all of this 0. Negative 1 plus 1 will give you 0, making all of it 0. And so, moving on, we just want to expand that out. So first we can start with x plus 1 squared. We know that x plus a squared is going to give us x squared plus 2ax plus a squared. So just replace a with 1, and we get x plus 5 into x squared plus 2x plus 1 is equal to f of x. And then now we just multiply x by all of these using FOIL, plus 5 by all of these using FOIL. Next up, we get x cubed plus 2x squared plus x plus 5x squared plus 10x plus 5 is equal to f of x. And then we just bring our like symbols together. So we have x cubed, 2x squared plus 5x squared, that's going to give us 7x squared. 10x plus x is going to give us 11x plus 5 is equal to f of x. And that is going to be our final answer. Okay, next up we have a similar question. Okay, so we want to write a polynomial of least degree with integral coefficients. So least degree means multiplicity of 1 across the board. That has given zeros of negative 3, negative 1 over 3, and 5. Let's just write down the zeros. Okay, and then we can just rewrite all of them. So it'll be x plus 3 to the power of 1. We're going to have x plus 1 over 3 to the power of 1, and x minus 5 to the power of 1, and that's going to be our f of x. But we need to note the fact that they asked for integral coefficients. This does not have an integral coefficient because we don't have an integer as the second number. This does have an integer and this does have an integer, but this one it isn't the case. So we can solve this by noting the fact that x is equal to negative 1 over 3 is the same thing as 3x is equal to negative 1, which will become 3x plus 1. So basically multiply the entire thing by 3. So let's rewrite that. And we get x plus 3, 3x plus 1, x minus 5 is equal to our f of x. And then we can start with these two. So just use FOIL. And so we get x plus 3 into 3x squared minus 15x plus x minus 5 is equal to 0. So 3x squared minus 15x plus, sorry, Yeah, 3x squared minus 15x plus x minus 5. Let's simplify that. Okay. And then again, we want to FOIL. So x by all of them, followed by 3 by all of them. So that will become 3x cubed minus 14x squared minus 5x plus 9x squared minus 14 into 3, 32, minus 15. And this is going to be our f of x. And then we just collect like terms, which will give us 3x cubed. Negative 14x squared plus 9x is going to give us negative 5x, I believe. Negative 5x squared. Negative 5x minus 42x is going to give us negative 47x minus 15 is going to be our f of x. And this is going to be the final answer. Okay, next up, we want to figure out how to find the vertex of a quadratic function. And so in order to find the vertex, we have to bring it into vertex form. Vertex form is y is equal to a x minus h squared plus k. So now one has to wonder how to get it into that vertex form. And so given y is equal to ax squared plus bx plus c, first off, you're going to bring the constant value over. So ax squared plus bx. Next up, we want to isolate x values. Next up, we want to remove any common factors. So let's say in this case we don't have any. And then next up, we will complete the square to get it into the form y is equal to some number, let's call it c, that would be our common factor. And then we have x plus a, let's not use a, x plus d squared. And then obviously, because we've completed the square, there's going to be an extra variable that we're going to have to take out, so let's call it e. Then you're going to want to bring the e over to get y minus c minus e is equal to, sorry, I used the same variable twice. Let's use f instead. F into x plus d squared. And then you're going to bring everything back on over. And we have y is equal to x plus d squared plus c plus e. And then now you just figure out h and k from the general form and plug in what your vertex is going to be. So let's do a couple examples of that. Let's say we're given the equation y is equal to 6x squared minus 12x minus 10. Sorry, plus 12x minus 10. So first off, we're going to bring the number on. So y plus 10 is equal to 6x squared plus 12x. Next, we want to remove any common factors. So y plus 10 is equal to 6 into x squared plus 2x. And next up, we want to complete the square. So for this part, let's just do it on the side quite quickly. We know that x plus 1 squared is going to give us x squared plus 2x plus 1. This means that x squared plus 2x is going to be x plus 1 squared minus 1. So we want to take away that extra one that we have left over. So when we go back to what we were doing, we get y plus 10 is equal to 6 into x plus 1 squared minus 1. Next up, we will want to bring out what this constant is equal to 6 into x plus 1 squared minus 6. We simply just multiply it by the constant. And then bring the 6 over. We get y plus 16 is equal to 6 into x plus 1 squared. And then just take that back. So y is equal to 6 into x plus 1 squared minus 16. Next up, just refer back to the general formula. We have h is equal to negative 1 in this case. And additionally, k is equal to negative 16. And so our vertex will be located at the point negative 1, negative 16. Okay, let's do a second example. Let's say we are given one that is a bit less perfect, and that would be the equation y is equal to 9x squared plus 27x plus 18. So again, isolate those x terms. Y minus 18 is equal to 9x squared plus 27x. Next up, we want to remove any common factors. So we're going to divide out the 9 and we'll get x squared plus 3x. Okay, and then now we want to complete the square. We're going to do it on the side in a different color. And so we know x squared, if we have, so we want to figure out what square will give us that 3x. And it's not as direct as the 2x. So we know that x plus a squared is going to give us x squared plus 2ax plus a squared. And so we want 2a to be equal to 3, which means that a squared, and this means that a is equal to 3 over 2. And this would mean that a squared is equal to 9 over 4. So all in all, this means that x squared plus 3x is equal to x plus 3 over 2 squared minus 9 over 4. We want to take away that extra factor that's here. So now, let's just plug all of that back in. And we get y is equal, y minus 18 is equal to 9 into x plus 3 over 2 squared minus 9 over 4. Let's put that all in brackets. And then you want to take out this factor so that it can be on its own. So we get 9 into x plus 3 over 2 squared minus 81 over 4 is equal to y minus 18. Next up, just bring that over, and we get y minus 18 plus 81 over 4. And that can also be expressed as y plus 2.25 is equal to 9 into x plus 3 over 2 squared. Now let's take it back into the general form. We get y is equal to 9 into x plus 3 over 2 squared minus 2.25. Refer back to the general form. And we have h is equal to negative 3 over 2, and k is equal to negative 2.25, which means that our vertex is going to be at negative 3 over 2 and negative 9 over 4 is what this corresponds to. And this will be our final answer. Okay, for our next question, we want to factor x cubed plus 8. We're going to use the sum of cubes, because we can just note that x cubed plus 8 is the same thing as x cubed plus 2 cubed. Now the sum of cubes will be a plus b into a squared minus ab plus b squared. Just plug in those values and we get x plus 2 into x squared minus 2x plus 4. And this is going to be our final answer. Next up, we're going to use the binomial formula to expand this out. So you want x plus 1 cubed, and we just need to note down what the binomial formula is. It just states that x plus y to the power of n will be the sum from k is equal to 0 until n of n, choose k, x to the power of n minus k, y to the power of k. So now let's plug in what we actually have. X plus 1 cubed will be the sum from k is equal to 0 to 3 of 3, choose k, x to the power of 3 minus k, 1 to the power of k. If we actually write that out, let's start with k is equal to 0. So 3 choose 0, x to the power of 3 minus 0, 1 to the power of 0, plus, next up, k is equal to 1, 3 choose 1, x to the power of 3 minus 1, 1 to the power of 1, next up, k is equal to 2, 3 choose 2, x to the power of 3 minus 2, 1 to the power of 2. Last, we have k is equal to 3, so 3 choose 3, x to the power of 3 minus 3, 1 to the power of 3. 3 choose 0 is going to give us 1, 3 choose 1 is 3, 3 choose 2 is 3, and 3 choose 3 is going to be 1. So the final answer will look like 1x cubed, 1 to the power of 0 is 1, plus 3x squared plus 3x plus 1. And then we simplify that, x cubed plus 3x squared plus 3x plus 1. Additionally, you could just use Pascal's triangle to figure out what the coefficients should look like, and they're correct. 1, 3, 3, 1. For this one, we're just going to use product sum. And so you want product sum, you want the product to be negative 40, and the sum to be 6. The two numbers that will give us that are going to be usually you can just think of them quickly. If you can't, just use the quadratic formula, and you should get 10 and 4. And so you're going to get x plus 10 and x minus 4 is equal to 0. And those are going to be your final answers. Solve for h. So we're going to divide out the L and the W. We are to isolate h, and we get h is equal to v over LW. And that's our final answer. Okay. And those are all of the questions that I have for you today. I hope you enjoyed today's Q&A. If you'd like to be notified of when we do post, be sure to hit the subscribe button and the bell right next to it. If you'd like to be able to post your own question, check out the links in the description. This has been Marlon from OneClass, and I hope to see you next time.
Hello everyone, welcome to OneClass. My name is Shanjida, and today I'll be going over some commonly asked math questions both at the high school / university and college levels. I am currently a second year human biology student. And also, in addition, if anyone needs additional schoolwork help or needs tutoring services, you guys could check out the description box below. And other than that, we'll get started. So our first question here says that how do you evaluate a secant of negative pi over 3? And so to do this, we should basically say what is secant of negative pi over 3. And so since we have a negative, we're dealing with a negative pi over here. So to convert the negative, basically the negative angle to a positive angle, so convert negative angle to like a positive angle. You basically have to do the following. Okay, so to do this, we basically have to add 2 pi to the whole angle. So we have negative pi over 3, negative pi over 3, and you have plus 2 pi, and this will give you a new angle, which is 5 pi over 3. So this is your new positive angle, and using this, we can basically find out the answer of the answer for our question. And so so if we recall that secant theta, or like any angle, is basically the same thing saying of basically saying the same thing as 1 over cos theta, right? So basically what we can say here, we can basically let's just say that cos theta is equal to 5 pi over 3, just for a brief moment here. So if we have this unit circle here, and from this unit circle we can evaluate pi over 5 pi over 3. And if you guys look over here, it's in the fourth quadrant, and you can see the x coordinates here, which is, so 5 pi over 3 is basically 300 degrees, and that is in your fourth quadrant. And in the fourth quadrant, cosine is positive. So cosine of 5 pi over 3, or I could just say, yeah, so I could basically say cos of 5 pi over 3 is equal to the coordinates right here, which is 1 over 2 and negative root 3 over 2, right? And so therefore we could also say, since so we are dealing with the x coordinate here, we're always dealing with the x coordinate, so we say that cos 5 pi over 3 is equal to 1/2. Okay, but however, since so this is just so like however, if you go back to our secant function, secant of 5 pi over 3, this is actually secant of 5 pi over 3. This is equal to 1 over cos of 5 pi over 3. Okay, and so since we said that 5 pi over 3 is a half, we are going to take the reciprocal of half. So we have here basically 1 over 2. And to take the reciprocal of that, you basically have 2 over 1 is equal to 2. So you have secant of x that we're trying to find out is 2 basically. And yeah, so this is, so we can basically say that secant of 5 pi over 3 is 2. And yeah, so this is right. Okay, so our next question says, find the exact value of tan pi over 6 plus pi over 4. Okay, so to do this, we should first state the formula, or like the tan identity of so a rule, which is, I'll just write down the question. Tan so it's pi over 6 plus pi over 4. Okay, so we have, so given the identity, we can say that it's tan. So the formula for a tan, an identity for tan is tan A plus B is equal to tan A plus tan B all over 1 minus tan A tan B. So this is the formula for a tan function, or an identity for tan. And so we can basically use this in order to find answer. So we can basically rewrite this by saying, tan of pi over 6 plus pi over 4 is equal, so let's just say that tan A in this case is pi over 6 and B is pi over 4. So we just substitute it into this equation. We have tan pi over 6 plus tan pi over 4 all over 1 minus tan pi over 6 and tan pi over 4. Okay. So further evaluated, we know that tan pi over 6, which is basically tan of 30, right? So if you say, so keep in mind that pi is equal to 180. If you recall that pi tan of 30 is 1 over root 3. Okay. And so you're adding, and tan pi over 4 is 1, which is so 45. So it's going to be 1. And then you have 1 minus tan pi over 6, which is also 1 over root 3. And you multiply this with 1. And so in the numerator, what we have is 1 plus root 3. We just take the common denominator by root 3. And then you have all over, so you have 1 minus, and then you have 1 minus 1 root 3. And then if I want to take a common denominator right here, you could say 1 plus root 3 over root 3. And all this divide this by root 3 minus 1 over. Okay, so I just took the common denominator in this case, and which is root 3. And so then I just multiplied and then got this fraction in the denominator. Next, what we're going to do, we're going to further simplify this. And we have, so if you do the top, basically have, you basically get, what we can do here, so 1 plus root 3 over root 3. And so if I want to flip this, you have times root 3 over root 3 minus 1, right? So this root 3 gets cancelled. You can basically cross it out, and you have root 3 plus 1 over root 3 minus. So then now what we're going to do, we're going to rationalize this function. And what I mean by that, so write down. And what we're going to do here, we're going to, basically what I mean by this, so this, we basically have, so, okay, so I'll just write this out, tan pi over 6 plus pi over 4 plus pi over 4, and then what you have, we got root 3 plus 1 over root 3 minus 1, right? And to rationalize this, what we're going to do, multiply this whole fraction by the numerator. So root 3 plus 1 and root 3 plus 1. Okay, we're going to multiply it by both the numerator and the denominator. And what we get here, we have root 3 plus 1 squared, right? If you multiply the top and the bottom. So now we get the bottom, which is going to be root 3 plus 1 root 3. And so further, we can further evaluate this. However, if you guys recall, this is a perfect square. So the formula for this would be a plus b squared, which is a squared plus 2ab plus b squared. And so we can rewrite that as root 3 squared plus 2 root 3 plus 1 squared, right? If you break the formula, and you have here root 3 plus 1, root 3 minus 1. Okay. And if you if you basically square root 3 or any root, it's basically going to be itself. So 3 plus 2 root 3 plus 1. And you have here, and you can, so if you look at the denominator, this basically resembles a squared minus b squared. So you can say that squared, and so you can further simplify this by, so we have 3 plus 2 root 3 plus 1, right? You can further simplify the bottom. However, I said that if you square anything, if you square a root, the root gets cancelled out with the square, and you're just left with that number. So in this case, 3. 1 squared is 1, and then you basically have 3 minus 1. And if you want to simplify this more, so you have 3 plus 1, which is 4, plus 2 root 3, and denominator you have 2. Okay, and so we can further simplify this by canceling out the 2 here, and you have, or you can divide this also, and this with 2. So you have 2 plus 2. And so finally, our answer is tan pi over 6 plus pi over 4 is equal to 2 plus they have got 2 plus. Okay, so our third question says solve v is equal to L times W times H for W. And okay, so this is a volume formula. So V is equal to L times W times H. So it's a volume equation or formula. So they're saying to isolate W in this case, or solve for W. And to do that, we basically have to move everything that's attached to W to the other side. And since everything's in a multiplication state, right? So I'll just say multiplication state. When it goes to the other side, it's going to change its operation, which it's going to become, so it's going to be divided with the stuff that's to the other side of the equal sign. So what we have here ultimately, so we can say B. So I'm just going to move the L, and it's going to be, and then if we move H, it's going to be down here too, and you have W. And so we can basically say that W is equal to V over L times H. So our next question here says, what is the nth term of the fourth term of the geometric sequence, given that its first term is a1 is equal to 5 over 2, and its common ratio is r equal to negative a half. Okay, so we're dealing with series here. And so to first solve this equation, we call the formula of the nth term of a geometric sequence, where the formula So it's called formula. So okay, formula for nth term. This is a geometric sequence. So we have here, so the formula is A is equal to A. So this is your first term, R of n minus. So this is where n is the nth term, your a1 is your first term, and r is the common ratio. Okay, and so since we are given here, so I'll just write this down. A1 is given as 5/2. R is given here as -1/2, right? So if you want to basically, so we can put this into our equation here. We can say that an is equal to 5/2 times -1/2 n to the power of n minus 1. And so in this case, we're trying to find the fourth term. And so to do that, we can just plug in. So we're trying to find the fourth term. And you can basically say that a to the fourth is equal to 5/2 -1/2, right? We're still keeping these the same. So only your n is going to change, which is 4 in this case, so 4 minus 1. And so you have 5/2 -1/2 the power of 3. Okay, and so to further evaluate this, term, you would get here 5/2, and then you would get -1/8, right? If you just cube this, you would get this answer. And so if you want to further simplify this, what you can do, you can multiply the top and the bottom, and you get -5/6. So a for the fourth term of the geometric sequence is -5/16. Okay, so our next question, number 5 says, if the quotient of a number and 6 is added twice to the number, the result is 8 less than the number. So we have to find the number. Okay, so we can say here that we first have to give a variable to the number so that we can represent it in some sort of way. And so we can say that let x be the number. Okay, so we're trying to find x. And so the expression above what we're given, we can write this into an expression by saying, so if the quotient of a number and 6 is added to twice that number. So if you have a quotient, so quotient means basically you're dealing with divisions. We can say that x/6, so plus twice the number, which is 2 times, right? So twice means 2 times that number, is equal to the result is 8 less than the number. So it's going to be x minus 8 since we're talking about the number, but it's 8 less than that. So it's going to be whatever the number is, you're just going to subtract 8 from that. So we have our expression. So what we're going to do is basically solve for x. And to do that, we should we should rearrange this so that everything is on one side, or we only have x, so like everything's on one side, and it would be easier to factor. So the first, what we would want to do, the first step would be to subtract 2x, or like move it to the other side. So we have x over 6 by itself. So we can say x over 6 is equal to x minus 8 minus x, right? And so now what we can say, we can further simplify this, and we get here 8 minus x over 8 x, right? 8 minus x, and so or minus 8 minus. And so what we want to do, get the x by itself, so we just want to move this over here, and it's going to be in a multiplication state. Since we're changing operations, it's going from the opposite side of the equal sign. And so what we have here, x is equal to 6 times all of this. So we can further simplify this, or evaluate it, factor it out. We have minus 48 minus 6, right? So x is equal to minus 48 minus 6x. And what we can further do is we can now we can put all the like terms on one side. So in this case, the one thing we could do is move the 6x to the other side. So you have, it's going to become 6x plus x is equal to negative 48. And so what we have here is 7x equal to negative 48. And so now, so this is just simple isolating the variable. So you have x is equal to negative 48, and then 7 goes to the other side, it will become division, so negative 48 over 7. Since you can't really evaluate this anymore, since 48 is not divisible by 7, so we can just leave our answer like this. And so if you want to recheck if this is the answer, you can put the x value into our equation, our first expression here, and see if it equals, so see if the right hand equals the left hand. So we can do this quickly right here. So our expression was x over 6 plus 2x equals to x minus 8. So just substitute x here. We have negative 48 over 7 all over 6 plus 2 negative 48 over 7 is equal to negative 48 over 7 minus 8. And so then what we have here, if you further evaluate this, we get negative 8 over 7, negative 96 over 7. So I just multiplied this out, and then you get and then this is basically equal to negative 48 minus 56 all over 7. As you can see, our common denominator is 7 in both cases. So we just further evaluate this. So negative 8 minus 96 is negative 104 all over 7. And this is, so negative 48 minus 56 is sorry, this is going to be negative. Okay, and then you basically get here, or no, this is going to be negative 104 over 7. Okay, you can see how both the sides equal, so this is right. And yes, but the so solution is correct. So next question says how to factor the trinomial 2x squared plus 5x minus 12. And so to do that, what we want to do is basically factor out. So when we're dealing with polynomials, the first step you would want to do is, so in this case we have 2x squared plus 5x minus 12. Okay, so the first step would be to find a number that when you multiply you would get whatever you multiply with and you get the answer. So like for example, 2 times 12 is 24. Okay, and you only have a middle number of 5, so you need to find two numbers that would, if you multiply them, you would get 24. And when you add them or subtract them, you would get the middle number, which is 5. Okay, so we can basically test out can basically say that what are the multiples of 24, right? 24, we have 1 times 24. We have 2 times 12. We have 3 times 8. We have 6 times 4, right? And these are mainly the factors. And so we can say that we can try out each of the ones that would add to 5, right? In this case, you can see that it won't be these two cases, obviously, because they're too big of a number. We can try 3 times 8, so we can say 8 minus 3, or this is supposed to be negative 20. Okay, so we can say 8 minus 3 is 5. However, 8 times negative 3 is also negative 24. So our two numbers would be 8 and negative 3. So now what we're going to do, we're just going to say 2x squared plus 8x. So instead of writing the 5, we're going to replace it by plus our two numbers, which is 8x minus 3x minus 12. Okay, now it's just simple factoring. So we're just going to factor whatever. So we're going to factor this by two terms. So you have here in this case, right? So if you factor out a 2, so what we can factor out here is a 2 and an x, since it's common in between these two terms. So we have 2x, factor out 2x, we're left with an x plus 4. Or we can take common here, we can take out a 3, since 3 is divisible, or 12 is divisible by 3, so you have minus 3, and you're left with x plus 4. You can check this by FOILing also, and you can check if it gives you the top expression, which it will in this case. Now what we're going to do is like combine the like terms. So our first term here would be x plus 4, and our next term here would be 2x. And so this is how you factor a binomial. So this would be our number. And this is 2x minus 3. So the is correct. Okay, so our next question says, what is the inverse of the function f of x is equal to x over x minus 2? That's supposed to be a minus. Okay. So we have here to solve. So we have to solve for the inverse function. We can basically, so let's say f of x is equal to x over x minus 2, right? So to find or to solve for the inverse, we'll just say, so let f of x equal to y. And so in this case, you have y equals x over x minus 2. Okay. And so then what we're going to do, we're going to interchange x to y and then solve. So then we're just going to interchange, so we're going to interchange x to y for y equals the inverse of the function. So this is how you write an inverse function. Okay. And so what we're going to do, basically we're going to say, since as you can see, we're letting y is equal to x over x minus 2. In this case, we're going to let x is equal to y over y minus 2. And then what we're going to do, we're going to cross multiply so that we have y by itself. So you're just going to cross multiply. So you have x, y minus 2, and this is just equal to y, right? And then what you have, you can just, you will just spoil this out. So you have xy minus 2x equal to y. So we have this. And so we're going to put the like terms, or we can basically say, we can basically move or put the y's together. And so then what we're going to do, we're going to move the 2x to the other side. So it's going to change its sign, and we have x y minus y. So the y comes to this side and becomes negative, is equal to 2x. Okay, and now what we're going to do, we're going to factor out a y from here, since it's common between these two terms. So we have y, what we're left with, x minus 1 is equal to 2x. So now we're almost there. We just need to isolate y in this case. So to isolate y, we need to move everything that's attached to it to the other side. In this case, we just have to move x minus 1 to this side, and it's going to be in a division state. So we have y is equal to 2x over x minus 1. Okay. And then what you have here, so this is how you solve for y. And so basically this is your inverse of the function f of x. So you can say thus the inverse of f of x, which is over x minus 2, is this is your inverse function, which is equal to 2x over x minus 10 is um next question says, what is a polynomial function? Okay, so a polynomial function is a function that consists of a sum or sum or subtraction of real coefficients. So say a polynomial function consists this uh um consists of a sum of monomials, so like basically a one term, it's made out of one term expressions with real coefficients. So it can't be zero, it can't really be zero. So of monomials, so like for example like with real coefficients, real so this means it cannot be zero. Okay, and so and non-negative integer exponents, so it can't really have a negative exponent. So and no negative exponent. So a basic outline of a polynomial function would be let's say f of x is equal to a x to the power of n plus bx n to the minus 1, and then you have plus c of x, and then you have plus a number, let's say x, this case, okay? And so where a, b, c are coefficients, all real numbers, okay? And you have to have a last term would be a number, any type of number. And so this is what a polynomial is. It's made out of different terms, and you can see n is the exponent. So the exponents are not the same. The exponents, so they have distinct exponents, so different for each term. So you can say this is one term, two terms, 3, 4. So polynomial has more than one term. Okay, and so that's what makes it a polynomial function. And so yeah, so a polynomial with only one term is called a monomial, which is a power function, exponential function, and yeah, so we can find the roots if you let f of x equals 0 and start the root. So yeah, so this. So our next question says how to simplify 3 over 15. So how to simplify 3 over 5 as a simplify the fraction. Okay. So if you want to simplify a fraction, we want it in the simplest form, both the numerator and the denominator by the greatest common factor. Okay, so simplify 3 over 15. Okay, so the greatest common factor between these two numbers is the largest number that is both divisible by the two numbers. And so in this case, you can see that 15 is divisible by 3, and 3 is divisible by 3 too. So the greatest common factor is 3. So in this case, you have 3 over 15. here 3 over 15, and you divide this by the numerator by 3 and the denominator by 3. What you have left is 1 over 5, and so you can't really, and then this is your final answer since you can't simplify this even more. So this okay. And next is list real numbers. List the elements of the given set that are natural numbers, integers, rational, irrational. Okay. So so the solution, so let's say for A, well, natural numbers. Okay, so natural numbers. Okay, so natural numbers are numbers are like positive whole numbers without zero. So positive they're positive whole numbers without zero. So in this case, we have, so in this case it would be for example, it would be 1, 2, 3, 4, and so on. So in this case, what we have here, so from the given list, we can say that root 16, which is equal to 4, right? So this is a whole positive number, so root 16 would be considered as a natural number. So now we can say for B, which is integers. Integers. Okay. So integers are numbers that are whole numbers and negative numbers, in addition to 0. So these are whole, positive, and negative numbers in addition to 0. So these are numbers like these are basically numbers like -1, so in this case, if we look here, our option, so this is a -500. In this case, the integer in this case would be -500. Okay. So C, which is rational numbers, so rational numbers. Rational numbers. So rational numbers are taking the ratios of integers. So rational numbers are taking the ratio of integers. So these are basically anything that with a decimal, 1.3. In this case, it would be 1.3, 1.33. It would also be also be 5.34. It would be 1 over 2/3, 1 times, or 1 and 2/3. It would also be 246 over 579, and it would also be negative, so this is a negative 20 over 5. It could also be that. And so the last one is irrational numbers. Irrational numbers. Okay, I also think negative 20 over 5, which is also equal to negative 4. This would also be, in this case, irrational number. The irrational numbers are like irrational numbers. So examples of irrational numbers would be something with pi, something that has a square root, and so in this case, that you can't really further simplify, like you won't get a whole number. So in this case, the only option left would be root 5. Okay, and so this matches. Okay. This matches. Yeah, 4. I said it could be negative 4 as well. I also said negative 20 over 5, which negative 4 is also an integer. Solution is okay. Okay, so our next says, how do you write 3x squared minus x minus 4 in factored form? Okay, so we have another factoring question here that says to say that, okay, so we have here 3x squared minus x minus 4. In this case, what we need to do is find a number that if you multiply, you would get negative 12, right? And that would add to negative x, or negative 1. And so let's first come up with the multiples of negative 12. So you have negative 1, 12, or negative 12 and 1. You have 6 times 2. You have 4 and 3. That's all basically. So in this case, you can probably imagine that this will not be the case. This will not be the case either, because it won't give you negative 1 if you add them or subtract them. So in this case, we are left with this pair, and we have, so we can say that 3x squared minus x 4. Use these two numbers, and we have 3x squared. So I'm just replacing the middle term with these two numbers. Since it's a negative, you would want your bigger number to be negative. So it's going to be negative 4x plus 3. Okay, so in this case, you can see here, we can take out an x and factor an x, and we have here 3x minus 4. Since there's nothing in common between these two terms, you can just factor out a plus 1, and you're left with 3x minus 4 So our end result would be 3x minus 4 and x plus 1. And yes. Okay, so next question. Next question says, what is sine of 2 pi over 3 equal to? Okay, so you have sine 2 pi over 3. So what is this equal to? So if you use, so basically if you use, you can basically evaluate this by saying, you guys recall that pi is equal to 180, whereas 2 pi is equal to 360. You want to convert it to degrees. And so in this case, that would be the easier case. And I would do, what I would say is sine of 2 pi, which is 360 degrees, over 3 over divided by 3, which will be 360 divided by 3, which is equal to 120 degrees, right? And so since it's 180, we can also further simplify this by 2 to get it into a range of 0 and basically pi, or pi over 2. Okay, so we want to find an angle that is in between these two. So if you simplify this even more, you would get 60 degrees. And so what would I would say that sine 60, if you guys recall the special angle formula, it would be 3 over 2. And so if you want to draw so quickly, you have your hypotenuse, or sorry, hypotenuse 2, you would have root 3, this would be 1, would be a right angle triangle, so this would be 60, this would be 30. And so sine 60 is root 3 over 2. Okay? And so sine of 60 is basically equal to that. And that is answer. So this what they've got. So the solution is correct. So basically that was the end of our session. If you guys like this Q&A, please subscribe to this channel, share and comment on this video. And other than that, I'm Shanjida, and I hope to see you guys soon. Bye-bye.